Welcome back to the deep dive. So today, we're putting on our protective eyewear and really digging into a comparison.
We really are.
It's one that couldn't be more critical for anyone involved in modern construction. We had a listener send in a whole stack of sources comparing structural insulated panels, SIPs, and they're looking for the absolute best material for, well, one of the toughest building environments in North America.
Yeah, maybe the toughest. The Gulf Coast.
The Gulf Coast,
Yeah.
Exactly. And before we even get to the panels, we have to talk about this environment because it's an unrelenting test for any building.
It really is.
When you talk about the Gulf Coast, you're talking about an ecosystem that feels like it's designed to destroy anything organic.
Right.
You've got intense, sometimes 100% humidity, just relentless, heavy rain, constant threats of flooding, and that salty air that just chews away at every single surface.
Exactly. And that's just the environmental side. Then you add the other threats.
The biological, the mechanical.
Yeah.
Yeah.
You've got category 3, 4, maybe even 5 hurricane winds. So that's massive uplift force, flying debris,
Native pests.
and the Formosan subterranean termite, which the sources all agree is pretty much the most destructive pest in the entire U.S.
So it's a climate where, a minor flaw in how you build something becomes this catastrophic failure decades down the line.
A multi-decade financial failure, absolutely. And our sources, they lay out this really clear head-to-head battle
They do.
between two major materials used in SIs. On one side, you have the traditional wood-based oriented strand board, OSB panels.
Stuff most people are familiar with.
Right. And on the other, this newer inorganic alternative, magnesium oxide or MGO panels.
And the argument in the research is just, it's immediate.
It is. It basically says MGO is engineered, specifically through its chemistry, to solve almost every single failure mode that OSB runs into in this hyper-aggressive region.
Which makes our mission today pretty straightforward. We're going to compare these two across 7 key performance areas that the engineers pointed out. And we're not saving the biggest point for last. We're starting with the one factor that determines if a structure even survives on the Gulf Coast.
Moisture. That's where the whole conversation has to begin. And honestly, it's often where it ends.
Right.
When we talk about moisture resistance, what we're really talking about is rot and delamination.
Right.
And that is the Achilles heel of OSB.
Okay, so break that down. What is OSB, fundamentally?
Well, just think about what it is. It's compressed wood strands. So organic material, all held together with these resin-based adhesives.
So glue and wood chips, basically.
In a very sophisticated way, yes.
Yeah.
But as soon as that panel absorbs water, which is just inevitable down there, 3 things happen pretty much at the same time.
Right.
First, the wood swells. And that swelling isn't temporary. It's often permanent. It deforms the whole panel.
And then second, that moisture starts breaking down the glue, right?
Yeah.
The adhesive.
Exactly. The constant wet and dry cycles break down that adhesive, and the wood strands start to separate. That's what delamination is.
And I remember the sources pointing out this just devastating consequence of that. It weakens the pull-out strength for screws and nails.
Precisely. That's the structural failure. If your sheathing is compromised, the fasteners holding your house together, they lose their grip.
So the whole structure is weakened.
The sources are really clear on this. Even chemically treated OSB is still, at its core, organic, and it still absorbs moisture.
Right.
If you have a flood event, say for 48 hours, that treated panel, it still degrades. And you're often looking at a complete replacement, a demolition job.
Okay, this all sounds like MGO is way superior, but let me jump in with a practical question, because there's a reason OSB is still the standard.
Go for it.
What about the cost? Did the sources talk about that? Is MGO just so much more expensive that builders are forced to choose the weaker, cheaper OSB?
That's a critical question. And yes, the reports did address it. They acknowledged the initial material cost for a high-performance MGO panel can be higher than just commodity OSB.
Okay, so it is more expensive upfront.
It can be. But the analysis immediately pivots to the long-term view. You're not just buying a panel, you're buying resilience.
The life cycle cost.
Exactly. The moment you factor in things like the reduced risk of a total structural loss, avoiding huge mold or termite repair bills, and not having to replace panels after a storm,
Then the math starts to change.
the MGO option moves much closer to parity, or even becomes the better choice for total cost of ownership over, say, 15 or 20 years.
So it's not just a material choice, it's like an insurance policy built into the walls.
That's a great way to put it.
Okay, so let's get to the MGO side of this. What's the chemistry that gives it this huge advantage against water?
MGO is a cementitious panel. Think of it like a very dense concrete board.
Cementitious, that's the key word.
It is. It means it's fundamentally inorganic. It's
Yeah.
not hydroscopic, which is a fancy way of saying it resists absorbing and holding onto moisture.
So it just doesn't get wet in the same way?
Right. The source material is emphatic. MGO does not swell, it doesn't warp, it doesn't delaminate, and it does not lose its structural strength when it's exposed to water, period.
And this wasn't just a manufacturer's claim, right? The sources pointed to specific tests.
Absolutely. This is all verified performance. We're talking about strict ASTM standards for water absorption, for wet shear strengths.
So industry standard testing.
Right. And while OSB might lose half its strength or more when it gets saturated, MGO is engineered to maintain its full structural capacity even when it's soaking wet.
So what, for you, the listener, is pretty stark here?
It is. Water intrusion is the #1 cause of building failure on the coast. And the real danger with OSB is that the rot. It often starts hidden inside the wall.
Behind the drywall where you can't see it for years.
Exactly. And that hidden damage is a ticking time bomb. It's a huge, long-term liability that MGO's chemistry just eliminates. It refuses to host the moisture in the first place.
And that hidden moisture creates the perfect environment for the next threat, doesn't it?
It sure does.
Because where you have moisture, you're going to get the whole biological ecosystem. Mold, mildew, and of course, that apex predator, the Formosan termite.
Which brings us right to our second segment, the biological invasion.
Let's start with mold.
Okay, so OSB is wood-based. That makes it a primary food source for mold, which just thrives in heat and humidity.
The Gulf Coast buffet.
It's the perfect buffet. Once that moisture soaks into the OSB, mold can just spread like wildfire. It compromises your indoor air quality, and fixing it is extremely expensive.
And the sources really hammered this point home, calling the Gulf Coast one of the most mold-prone environments in all of North America.
It is. It's that perfect storm of heat, moisture, and organic building materials.
So if you build with the food source, the mold is going to show up.
The MGO advantage here is, well, it's definitive. It just removes the invitation completely. The board is 100% inorganic.
No wood, no cellulose.
Nothing organic at all. So mold and mildew simply cannot grow on it or in it. There's no food for them. And the research backs this up with ASTM D3273 testing, which confirms it's totally resistant to fungal growth.
Okay, so no mold. Now let's talk about that apex predator you mentioned.
The Formosan termite.
We're moving from something that grows to something that actively destroys.
Right. And OSB is highly vulnerable to pests. Termites, carpenter ants, rodents, especially down near ground level.
And I imagine when the OSB gets wet, it gets softer.
Makes it even easier for them to burrow in. Exactly. Yeah. And we really have to stress, we're not talking about your average termite here.
No.
The Gulf Coast is notorious for Formosan termites. They swarm aggressively. They can structurally compromise a standard wood frame house in a matter of months.
So this isn't an inconvenience, it's an existential threat to the building.
It's a constant maintenance battle. And what's fascinating is how simple the MGO solution is.
It's almost brute force in its effectiveness.
It is. It's simplicity based in chemistry. MGO is cementitious, so it behaves like concrete, like a rock.
So insects just can't eat it.
They can't eat it, and they can't burrow into it. They just move on to find a softer, more organic target.
So you solve the entire pest liability for the structure.
Right, from the foundation up. It's a fundamental difference. It's not a chemical treatment that wears off. It's a physical and chemical impossibility for the pests.
That kind of foundational integrity has to hold up against more than just termites, though. It has to hold up against brute force.
Which brings us right to segment 3, the extreme performance demands.
We're talking fire, Category 5 winds, and long-term structural life. Let's start with fire, because the comparison here is really dramatic.
It really is. I mean, OSB is wood. Wood burns. It burns quickly. It provides fuel for a fire.
And to meet code, you have to add chemicals to it.
Right. You need added fire retardants just to meet the minimums.
Yeah.
And even then, when OSB burns, it creates a lot of heavy smoke and toxic fumes.
MGO, on the other hand, is naturally fire resistant. And this is where we get into the really cool technical side of it.
It's classified as non-combustible. It gets a Class A fire rating right out of the box. 0 flame spread, 0 smoke spread.
But how? How does it do that without added chemicals?
It's the chemistry of the material itself. Magnesium oxide contains chemically bound water molecules within its structure.
Okay.
When that panel gets exposed to the intense heat of a fire, it triggers what's called an endothermic reaction.
Meaning it absorbs heat.
It absorbs the thermal energy to release that trapped water as vapor. So it's basically releasing steam, which actively cools the surface of the panel and prevents it from ever igniting.
That's incredible. So the wall itself is acting as an active fire suppression system.
It's a thermal barrier. It's fighting the fire chemically, not just physically.
It resists the heat. It doesn't add any fuel.
And critically, it minimizes that smoke and toxic gas, which is often the biggest killer in house fire.
And the sources had that unbelievable anecdote that really drives this home.
The Canadian wildfire case,
Yeah.
in Tatasqueyac.
After the fire moved through, the MGO panel structure was, and I'm quoting, the only building left standing.
That is resilience defined by chemistry right there.
So let's move from fire to wind and impact. Hurricanes.
The demands are huge. Gulf Coast homes have to be built to withstand winds from 120 up to 180 miles an hour.
Plus flying debris, 2x4s acting like missiles.
And constant wind-driven rain.
So in that scenario, what are the main ways that OSB fails?
Its weaknesses just get amplified. First, like we said, its strength plummets when it's wet, right when the maximum force is being applied.
The worst possible time.
And second, the seams between the OSB panels are notorious failure points during uplift events when the wind is trying to peel the roof off.
Okay, I get that MGO is stronger, but it's still a panel with a foam core. Did the sources mention any specific failure points for MGO systems? Like, do the sealants break down or?
That's a fair question. No system is an island. The sources did stress that you need high-quality, compatible, non-organic sealants at the joints.
Right. The whole system has to work together.
But the performance data showed that high-density MGO panels, especially when they're tied together properly with steel fasteners and reinforcements, they handle the immense shear and uplift forces far better.
Better than OSB.
The research says MGO assemblies significantly outperform wood SIPs and even standard plywood against impact loads. They're just harder, denser, and less likely to deform under that kind of force.
And that superior strength leads right into our last point in this segment, longevity.
Longevity ties right back to moisture and temperature cycles. OSB is prone to long-term decline.
Constant swelling, warping.
Fungal decay, delamination. Those high heat and humidity cycles are constantly attacking the adhesives holding it together. So the structural capacity of the building is actually declining slowly over its entire lifespan.
It's like it's aging from day one.
Essentially, yes. MGO, on the other hand, it offers what they call structural permanence.
Because it's cementitious.
Exactly. It has extremely high dimensional stability, which is key in a place with wild temperature swings. MGO panels barely expand or contract compared to wood.
Which means less stress on all the joints and seals.
Right. The claim from manufacturers, which is backed up by long-term analysis, is that these panels can last for decades with no significant deterioration. You're shifting from a material designed to decay to one that's designed to cure and last.
And that idea of permanence brings us to our fourth and final segment, which is the environmental impact of these choices.
Yeah, for a lot of builders and homeowners today, this is a massive factor.
We often just assume that wood is automatically the green choice, but the reports pointed out some real downsides to OSB manufacturing.
They do. I mean, yes, wood is renewable, but mass harvesting contributes to deforestation. And the manufacturing process for OSB, it uses immense heat, resins, and adhesives that produce VOCs.
Volatile organic compounds.
Which are not great for indoor air quality and are a big factor in pollution from the plants themselves.
And MGO is different.
This is a point where MGO really shines. The manufacturing is much cleaner. It's a low-emission process.
And the sources highlighted one really surprising fact about it.
This is the amazing part. It cures at low temperatures. And it actually absorbs corrosion from the atmosphere. During that curing process, it's called carbonation.
I honestly had no idea. The idea that the manufacturing process can actually absorb Kuro, that completely reframes the whole green building debate for me.
It's a huge plus on the sustainability side, an active carbon sequestration feature.
Wow.
And on top of that, MGO is safe for landfills.
Yeah.
No ecological harm reported. So the overall environmental footprint, especially with air quality and emissions, it really favors the inorganic panel.
So that brings us to the final synthesis.
It does. If you are building in the Gulf Coast, or really any high-risk environment with moisture, pests, and storms, the choice is between resilience and compromise.
The analysis just summarized the failures of OSB so perfectly.
They rot, they mold, they swell, they burn fast, and they're food for termites.
And the MGO panels, just because of their inorganic nature, they solve all of those fundamental problems.
They hold their strength in water. They have that innate fire resistance from the endothermic cooling.
And they just don't provide a food source for all the biological threats that define that region.
It's a material designed for survival in a place that is, well, unforgiving.
So the core takeaway for you, our listener, is this. When you're choosing between MGO and OSB in a hostile environment like the Gulf Coast, you're not just picking a sheathing material.
No, it's a much bigger choice.
You're making a fundamental choice between potential long-term liability and proven long-term resilience. OSB fails exactly where the coast is strongest, with humidity, storms, and pests. MGO is engineered to solve those core failures.
Offering a structure that's designed to stand for decades, and as we discussed, likely offering a lower total cost of ownership when you look at the big picture.
And that leads us to the final provocative thought to leave you with.
If these cementitious inorganic panels like MGO are proven to be superior across the board in resisting fire, water, and pests, the three great enemies of construction.
Then what does this tell us about the future of our building codes and safety standards?
Exactly. As our global climate becomes more extreme, should we start moving away from traditional organic building materials entirely, at least in these high-risk zones?
It's a powerful question. Will future building codes start to mandate the most resilient materials available instead of just accepting the most traditional ones?